Hey everyone, thanks for joining us for the CIMCO webinar. My name is Jake Montgomery. I'm here in technical sales for QT. Some of you probably met me through training or through support or even on site. Today we have Ryan Mermall with us from CIMCO Americas. He's going to be covering a whole suite of products that are add-ins for Mastercam that hopefully will make your Mastercam experience better as a programmer, as an operator possibly, whatever your role is. Some of those are going to be CIMCO Edit integration. It comes free inside of Mastercam. There's also a pro version that's got some added features that Ryan will talk about. We also have CIMCO Verify, which is recently new. It's a more enhanced kind of Mastercam Verify on steroids, along with machine simulation. And CIMCO Probing inside of Mastercam. During the presentation, Q&A is open, so if anyone has any questions, comments, don't hesitate to ask. I'll be on there. We've got a few other guys that will be able to help. And then afterwards, we'll run about an hour today, 45 minutes to an hour. We're going to leave the Q&A open for about 10, 15, 20 minutes. We can kind of work through some questions if you guys see something you're unsure about. Have more questions, want to know more information, don't hesitate to reach out. With that being said, I'll hand it over to Ryan and see what he's got for us.
Yeah, appreciate that, Jacob. I just started sharing my screen. I hope everyone can see that. Are you guys able to confirm, Jacob?
Looks great on my end.
Perfect. Yeah, that sounds great. So appreciate that as always. So as Jacob mentioned, my name is Ryan Mermall. I'm the Midwest area manager here at CIMCO Software, and then also the CIMCO Probing kind of product manager as well. So as Jacob mentioned, we'll kind of get an overview as far as some of the integrations that we offer within Mastercam to obviously help your programming, whether that is the one of the newer products of CIMCO Verify, which we'll get into shortly, or even the probing, or even the machine simulation as well. So a lot of you may have heard of CIMCO in the past. Hopefully you've heard of us. If you have, perhaps it's through the editor that we include with the Mastercam installation itself. For those that maybe don't know, we do have a version of our CIMCO standard version of the editor within Mastercam. It is kind of a stripped down version, although a lot of clients actually end up upgrading that license to a professional in order to get some additional functionality. One of them most commonly being the back plotter, and then possibly adding on the machine simulation module itself. You'll see on my particular screen here, I do have my editor open using my 2022. And so with that being said, I went ahead and actually generated out the code and everything from Mastercam.
Hey, Ryan.
Mm-hmm. Yes, sir.
Your screen's frozen. Sorry to butt in.
Ah, that's okay. Let me try sharing again, make sure it didn't try doing a window. I just gotta see which one it is. I don't know if it's picking up on my third monitor.
Yeah, when you've got multiple windows like that, they're all over the place.
Yeah, that's okay. Let's try that one. Are you able to see the editor now?
Yep.
Okay, perfect. I'll just shift monitors over to my additional one there. So as I mentioned, with the Mastercam, we do have, again, a number of integrations within there for kind of ease of use and organization. I just created a CIMCO tab along the top menu bar here. That way I can go ahead and kind of keep everything straight. What I ended up doing is generating basically the NC file, along with then pushing out the information to my fixtures, my stock, my tools. All of that's done within what we call our edit integration, which is for either backplot and or machine simulation itself. So as you can see within this window, we can certainly pick on the specific machine. We can tell the different pieces of information, such as my workpiece, the fixture, the stock, enter everything to it, of course. What that'll actually end up doing is creating a number of files within a folder. And so in that particular case, we have our G-code file along with what we call our setup file and STL files within there. What that's going to do is when I go ahead and actually launch the backplot and or machine simulation, it's actually going to be looking inside of that folder for the STL files, of course. And then that's going to allow me to get that loaded up within the software and bring that in for us. With that being the case, again, we have kind of the two differences. We have the backplotter itself, which is going to be to plot out the code, whether it is something through Mastercam or maybe handwritten from years ago. Either of those can certainly be utilized within here. And then, of course, I'm just adding in some additional options such as your fixtures and your stock and your workpiece. Again, pretty much all coming from Mastercam, along with then all the tools set up as well. So what that allows you to do is actually to go in and improve out what your program is. Obviously, one of the main features to it is that it's actually reading off the G code itself and not necessarily the raw toolpath cutting data. And so that is going to be shown live here. If there were to be any, weird Z moves or anything that it would obviously be detecting that would obviously cause issues out at the machine itself. So in this particular case, I just go ahead and have a drill. My drill's actually oversized at that case to kind of show some information, for potential collisions as part of it as well. With that being the case too, if there's anywhere specifically in the program that you wanted to jump to, kind of a nice feature is you can actually click on that particular line. The backplotter is going to go ahead and jump to that specific one and show you where it's at exactly in the program itself. From any time, you can certainly jump around lines. You can backplot certain sections by it, whatever the case may be, in order to utilize it correctly here. Like I said, this is all within just the backplotter by itself. We can also then, if needed, to run that through our machine simulation, which would actually go ahead and take into account any of the machine models and also their limits. So collision checking would be part of that, along with then being able to check against a limit if we're going to over travel or whatever the case may be, and certainly go ahead and bring that in and do its thing as well. The nice thing with the machine simulation is, again, it's kind of that natural process from bringing it in from Mastercam to backplotting to also then running through a machine simulation. Along with that, a lot of different information we can do as far as checking against, again, collisions and getting that in a report format. We can also, some of the new features within the editor that we've added in fairly recently are going to be different things as far as like a compare feature. And so a stock compare allows you to actually go in and give it some type of tolerance, value to it, and kind of take a peek at where that falls. Obviously, from an op1 standpoint, you can see I'm green, in these areas, but obviously you have a remaining stock on the bottom for like a side 2 or an op2, more or less. The other thing too is we've most recently added in a zoom functionality for the zoom window, and so that's going to go ahead and refresh the graphics based on that specific area, kind of freshen that up, and again try to get a better idea as far as what's going on. And all this is using our what we call our fast version, which again is kind of a newer simulation kernel that most recently has come out. So a lot of cool things, there, of course, along with then also doing some different information on being able to actually go ahead and do like a cross-section view, in that particular case. So if there's a certain area on the part you were hoping to get a better, kind of look at, in addition to possibly even doing a comparison, you can certainly section that off and take a peek at what that's specifically going to be looking like for the part. So a little bit there on the backplotter and machine simulation side of things. one of the other things I'll maybe jump into right away would be the edit verify, and kind of give you guys a sneak peek as far as what that is concerning. Obviously, I think everyone's probably heard of the standard, verify that's come within Mastercam. This would be ahead and good within Mastercam as well, except for it's using our fast kernel as far as the simulation. So this particular case, obviously, we just have, a larger mold, fairly large file, would take quite a while to get into the verify itself. But within the edit verify, what we can do is through a similar navigation window, we can tell it different pieces of, the part itself. Do we have a fixture or stock? Do we actually want to go ahead and do any simulation as part of that as well? And this one specifically is actually going to be going off the Mastercam NCI file. So it's not going off the actual G code like we were originally looking at there, where now this guy is actually going to be going off the NC file. But with that being the case, you can get it loaded up. We maybe set our quality to a higher level there. And if wanted to, we can certainly play that through and have it go ahead and simulate to maybe the end of the file, and just kind of take a peek at how fast, that actually is. Now, I like to show this one first. Again, that way you can kind of get a rough idea as far as the timing, probably a 10-15 second, more or less to get loaded up, run it through verify. Obviously, there's different things within here as far as stop conditions, where you can stop on a collision or tool change, some of the standard stuff you may use, along with then again, doing like a comparison or cross section, based on that as well. Now, again, everything's going to be based on the NCI file as part of it. And if I were to, again, kind of give you a comparison loading up to maybe a standard verify that you'd be used to, we'd basically let that sit there for a few minutes to get started, just to get loaded up into, obviously, the system. So this guy's actually coming over here to this side. Right. But obviously by now, the edit verify with everything would have vastly been, taken care of and already done. So kind of give you an idea where we're at as far as, speed wise is concerned, of course. So obviously I'm not going to bore you guys to death with having to wait there and watch that, go. But obviously if there's any questions or, want to take a further look at your guys's, specific parts or examples, we'd definitely be more than happy to run it through. And it does come with a free 30-day trial as part of that. If you are interested in maybe learning more about it, that one you could actually go to CIMCOverify.com and take a peek from there, of course. So with that being the case, let's maybe switch gears and kind of jump into maybe one of the main sections and reasons why we're here. Obviously, the CIMCO Probing, side of things. With that being said, you may or may not have heard of CIMCO Probing. It's going to be, again, obviously an integrated product within Mastercam. It's going to be utilizing the standard macros that are already found, probing macros that are already found on your machine, generally shipped from the factory or installed by Renishaw or other machine manufacturer.
Hey,
and so,
hey Ryan,
yes, sir.
We're on your CIMCO edit screen.
You're on what again?
Your CIMCO edit screen.
Interesting. Sorry. So did you guys not see the verify?
Mm-mm.
Interesting. Why is that doing that? It definitely told it to do a window.
Can you have it select the screen by chance?
Yeah, let me try that again and see. Okay. Let's try it.
Okay. Yep, we got your Mastercam screen now.
Okay. Interesting. My apologies for that. Let me just quickly kind of go back through on the verify side of things and run back through it. So obviously with the verify, here I have just a larger mold, obviously, that would be doing a lot of, say 3D machining on, for instance. So with that being the case, again, very similar to the edit integration, we have a utility that's going to allow you to pick on, say your workpiece, your fixture, your stock, and also then, possibly do a machine simulation as part of it. Again, all going off the NCI code itself. But to give you an idea again on kind of the speed wise, that should go ahead and pop up. And Jacob, can you just verify you guys are seeing that window too?
It's beautiful.
Perfect. Yep. So obviously there within a matter of seconds, right? That's going to go ahead and pop up with us. We can also then zip it to the end if we'd like, and have it go ahead and actually run that through simulation. And then of course we can certainly have different stop conditions as part of it for collisions or tool changes, whatever it may be, of course, and kind of get an idea of the verification, side of things. So again, that took, probably 10 or 15 seconds, start to finish, more or less. Generally on the larger part files is where you're going to see a bigger and better, kind of return on that, of course, because launching it into more of a traditional verify, we'd go ahead and see, this guy here is going to sit for a bit of time, loading and loading and loading, where obviously the edit verify is going to be utilizing the standard fast version kernel within the software. So to kind of give you an idea as part of it, of course. So like I said, the edit verify can actually be found on the website of CIMCOverify.com. And if you wanted to kind of take a peek at that and learn a little bit more, that would certainly all be there, of course. So, and obviously we'd be happy to certainly, schedule a time to review your guys' products and, parts specifically if that'd be of any interest, of course, too. So, on the actual probing side of things, like I said, if you wanted to learn a little bit more about it, as far as our website's concerned, that's just going to be the website of probing.com. And so with that being the case, you'd be able to download the product, right from there, or ask any questions, whatever it may be, of course. Like I mentioned, it is going to be utilizing the standard macros that are installed on your CNC machines. So with that being the case, most of the time here in the States, we obviously have Renishaw. So you'd be actually referencing the Renishaw Inspection Plus macros. And so if I actually take a peek at my Mastercam, we'll kind of give you an idea of a workflow, going through it. So Jacob, again, can you verify you're seeing the Mastercam, right?
Yep, looks great.
Okay, great. So on a case like this, right? Maybe we're starting off with some again raw stock in that case, and maybe I'd want to actually go through and touch off our X, Y, and Z, to start, and then maybe somewhere through the program, we want to go ahead and actually do some type of in-process inspection. And just to kind of give you an idea, Verify is now ready to go with it actually just being loaded. So now would actually start the time to start running through Verify, just to, again, kind of give you an idea of timing. But within the CIMCO probing side of things, what we would have is, again, a menu or an option where we would go ahead and be able to select on our particular cycle. In this particular case, maybe I want to, again, touch off my part to start. And so by going through the software, we have different categories, whether it's going to be aligning the actual workpiece, setting an actual datum, or going through with a in-process kind of inspection. That's also where you'd be able to set some tolerances and also do some remachining, based on the part. But to start, what I would do is maybe like a workpiece datum, kind of get an idea as far as what category and process of elimination on the part that I'd like to do. Maybe to start, I would do like a 0.1 axis and touch off on my Z. We can establish that and then come back through and establish the X and the Y. So if I go and launch that operation, It's going to go ahead and launch within the software. Now, in this case, I already have a probe defined. If we don't, you could simply right click and go to the tool manager. And again, it's going to load up a standard tool manager from within Mastercam, and to be able to grab it out of your library as needed. With that being the case, we can certainly say, set G54, we'll say Z0 on a case like that. And then we can go to the cycle tab, right click, and then associate to, depending on the cycle, different pieces of geometry. In this particular case, we're just going in a one axis direction. So I can go ahead and do a select of points. We can either select it right off the model, or using any of our auto cursor, kind of options, you'd be able to define where that's specifically going to be. With that, in this case, we're going in a Z negative direction. The measuring height would be theoretically at Z0. Our safety distance we can punch in along with our clearance height as well. Now, right away, you're going to be able to start getting an idea visually on our part where that probe hit is going to be. And I can certainly go ahead and tell it other probe hits, depending on where it is. Or in that case, that was actually a misclick. So I can go ahead and just remove that one. But then you'd be able to modify anything to that specific cycle that you're wanting to do. Perhaps it's, put in an over travel, distance as part of it. What work offset number, do we actually want to update on the machine, of course. Now, in this particular instance, this is just for a Haas using the Renishaw Inspection Plus, but obviously we would support much more. Most commonly it would be like a Fanuc or a Kuma, Mazak, Matsura, whatever it may be. And again, we can certainly visit that to see if obviously your guys' specific machines and controls would certainly be supported. So if I go ahead and create that cycle, you're going to notice that is a true or a valid operation within my Mastercam tree. We can certainly bring that through backplot, verify, machine simulation, whatever it may be, and take a look at what that is actually doing. Now, in this particular instance, it's just coming down in the Z-axis, so pretty uneventful. However, if we go ahead and maybe combine that with doing like a rectangle outside feature, that way we can touch off on X and Y, then we'll run both of those together within the, say, the back plot, and then finally, obviously, post out the G-code and take a look at what that is doing. So we'll just give it an operation comment. That way I can kind of take a peek at what that is. I can right click within the area here. And then again, because of it's a different cycle, we're going to allow for different things. This one, you can see we have from stock, lines, or chains. The from stock is going to ask me which stock plane do we wish to use. In this case, I'm going to be referencing my top. If I was on a horizontal, generally I would want like a front plane from there. But with that being the case, then again, we can start defining specifics to the probe path. Maybe it's the, again, the measuring height, the safety, and the clearance height. We can go ahead and punch in. Now, it's simply, I typed in a number there. You can certainly right click and use some of your options as far as like Z coordinate of a point, or even use your center mouse wheel in order to scroll up or down, as that's going to increase or decrease the value. That way you can get a proper visual of the probe path before actually confirming and checking out of the part itself. Again, we'll set G54 in that particular instance as our updated work offset. Now, within there, because I already had a previous probing operation, perhaps I'd actually want to suppress the probe on and off in between cycles. So that's certainly something you could do there. We do also allow for different variables to be set as part of that. So if you wanted to actually set the true width of what that actually measured as, you'd be able to give it a variable number within there, or maybe even the deviation, portion of it, whatever it may be. You'd be able to then, again, copy those results into specific variables that you define yourself. So if I were to take, say, both of those operations together, now obviously we'll notice that we have our Z-axis touch off, along with then, of course, the X and the Y-axis side of things, naturally setting the center of the part as my 0 position for G54. And of course, lastly, if I go ahead and post that out and actually take a look at what the code is going to look like, you'll notice that we are in fact referencing again the standard inspection plus macros. So obviously we have our probe on, we're getting there safely with our 9810 moves. And then because I'm doing that 0.1 axis, that's going to be this 9811 setting at Z0 over travel and G54 being my work offset. Obviously we're getting out of the part safely. Notice we're also suppressing that probe off and back on between cycles. But then again, we get into our X and Y axis here down below. So here's our X axis and then our Y axis before getting out of the part and shutting the probe off and going back up to our home position. So different things you could obviously do depending on what you're obviously going after from within the software itself. Like I mentioned, setting just a standard, say G54 or extended work offset, whatever it may be, could certainly be kind of an entry point into it. But also, being able to take that and do some more complex or advanced, sort of routines. Maybe it's doing some remachining as part of it. So for instance, if I had like a center bore cycle within there, we'd have that actually as a finish contour, using like a wear compensation in this case. What I would be able to do is actually go into like a workpiece inspection category, determine, okay, do I want to set that up in a 4-point or 3-point method? 3-point will actually allow you to define the specific vector angles that you'd want to do. Would be good for like these half moon shapes down at the bottom of the part there. But in this particular case, I'll do like a 4-point method. And same type of workflow where we'd actually go in and set that up, except for now this time, you're going to notice after I set up that cycle that we're going to have kind of a few more options, obviously, as part of it. So you can determine, is that okay on motion? Do I need to turn on a safety distance because I'm inside of a bore at that case? If there's a feature or something that's going to be an instruction, we can certainly lift up and out before moving over to the next position, of course. But otherwise, most importantly, we can then tell it different, again, measurement results. Or in the case of remachining, we can do like an if-then conditions. The if-then conditions, in our case, we consider the part to be in one of 3 conditions. It can either be scrap, it needs remachining, or it's within tolerance. If the part is scrap, what do we want to do? Well, I generally don't want to continue on creating a bad part and wasting more time on it. So perhaps I'll do like an M0 to stop the machine, or maybe even a manual entry. And then that way I could maybe even do like a pound 3000 equals 1, and do like a bore too large or something like that and give it a kind of a custom alarm message for the operator, right? We could also then, if needed to do remachining, we could go to an operation, and that operation I'd want to loop back to is going to be my finish center bore cycle, and that's going to be that contour that I want. And then if it's within tolerance, we'll just continue on in the order of operations by itself, of course. As far as setting up, specifically to tell it when to do remachining, when not to, things of that nature, we would go ahead and set up some of these tolerance values down below. You'd be able to kind of determine what's the tool offset number we want to update, if you do in fact want to update the tool. In this case, we can do automatically based on what Op13's tool in fact is. We could also give it different either remachining tolerances and even a dimension tolerance, depending on, again, what you're going after. But maybe I want to say remachine if it's greater than or less than, say, 5 thou within there. If you want to use what we call our H or dimension tolerance for Renishaw to either flag or alarm out the machine, you could certainly tell that as well. With that being the case, I could also tell it, if you do in fact need to adjust the tool, when do we not want to chase, generally tenths, right? So for the tool adjustment tolerance zone, I'll usually go like 2 tenths as far as something like that to say any repeatability or whatever it may be. Don't always adjust the tool, based on there. Some of the last things we'll do too is like feedback percentage. Let's say we're 10th thou off. If I need to update the tool, do I want to update the tool by all 10th thou, or do I actually want to give it a percentage of that and maybe go like 60%, which would then update the tool by like say 6th thou, right? You'd be able to kind of determine that as well. Along with using like an upper tolerance limit as more of a safety net in case there was like a chip on the probe or something like that, to say, nope, this is more than I feel comfortable with updating the tool automatically. So for your particular instance, you might use a combination, all of them, none of them, you know, whatever it may be. Again, just knowing that the functionality is obviously there and able to set the tools and the probes up for the cycles the way that obviously you would need to use them. For more of a complex kind of situation. If I were to take, say, both of those operations together and post them out, obviously that's going to open up within my CIMCO editor. And so if we kind of go through and look at the code, one thing you're going to notice is right away we're going to automatically create a restart label. So no need to create any labels as part of it. We're going to handle that for you. Obviously, we call up our finish tool itself, turn on our compensation and run that through the cycle itself to finish up that bore. Then obviously we switch over to our probe, do a standard measurement in which then we're giving it all these different pieces of information, again, depending on what you're going after. It's going to store that data, and then it's automatically going to read our if and greater than, less than logic. So in this particular instance, we're referencing a 193 variable, which happens to be for Renishaw on a Haas, our size deviation. So we're trying to hit a 1375 diameter. Whatever the deviation is going to be placed here in 193. And then, of course, it's going to be either greater than, less than that tolerance I told it, and then go to the different areas on the part itself, or in fact, continue on as normal if it is within tolerance. So again, just different areas of use that you could certainly use on it. Again, depending on kind of what you're going after as part of it. Otherwise, you know, with any of the options or the inspection and or datum cycles for that matter, obviously you could also, you know, print out the data using Ethernet or deprinting, possibly even utilizing like our CIMCO like DNC Max product or data collection in order to collect all that data and possibly even store it within the databases for future or historical reference. So hopefully that was kind of a broad overview as far as the products, kind of getting into some of the specifics here as part of it. So Jacob or anyone else, is there anything you know, possibly to add you know, on top of that, of course, or any questions that you're seeing?
I don't see questions. I think it was great. Had a few hiccups, but we managed through it. You did awesome.
Yeah, apologies for the screen sharing.
No big deal.
Don't know what was going on there.
No.
We will obviously have a video recording of it, so we'll make sure to snip that out of it as well. So
yeah, perfect. Does anyone have any questions, comments? Anything on probing? I know I see a few, you know, Jesse Ricks. There's a handful of guys in here that are active probing guys that I've worked with. A lot of new names. Okay. Well, I don't have anything to add. Chris Deckman said, very cool, thanks. Perfect. Matt Wood said, is there a way to probe two bores and have CIMCO calculate the offset based off the average of the two?
So you would, in that particular instance, you would probably want to do some like FANUC macro B kind of programming, assuming we're talking about the bore sizes themselves. People also do that with like flatness, you know, checks. So obviously like CIMCO's involvement would be to be able to run the probe and gather that information for the bore cycles. And then, of course, I would recommend taking that either deviation or actual, storing those two specific variables, and then you'd be able to say, this variable plus this variable divided by 2 obviously gives you the average, between them. So that's something I would recommend kind of doing, that way as well. So.
And that'll be Fanic Macro B is totally outside of CIMCO, correct?
It is correct. Yeah.
So,
yeah. Working as CNC lathe operator. How can I find training on CIMCO training for lathe programming? I don't know if we don't necessarily do, say, lathe programming training, for instance. If you're looking for Mastercam programming on the lathe, obviously the guys at QTE would certainly be able to assist with that. The probing side of things is going to be on the mills only 3 to 5 axis at the moment, although we are working on lathes in the mix, just not ready for prime time just yet. So,
yep. So I'll send you my email. I believe I'm pronouncing it Tran. I'll send you my email, and you can we'll be able to help you more offline if there's whether it's Mastercam or G-code programming. We'll try to figure out what exactly you need. Awesome. Joel asked, what is involved on CIMCO's end for the machine simulation? Do you need to build it based on our information, or are there available defaults that we can choose and set up ourselves?
Yeah, great question. So it depends, pretty much around what machine, itself you'd be actually needing to simulate. And so, for instance, we actually have a number of built out machines, all of them in this case being Haas currently. The main reason is because Haas is very open with their models, and obviously host them on Haas's website, which allows us to go ahead and actually build these out and host them internally for our end. Not all machine manufacturers are that generous, and a lot of them require either NDAs or even purchasing of the machines. So in short, if you are needing to set up a machine, if we have it here on our servers, that's great. It's available to use with the machine sim license, add-on license. Otherwise, if we don't, then that machine models would have to get either built by you guys or provided by the end user, and then either can be built out by by us or by possibly QTE, or even yourselves as a user within the software. So. And be able to obviously associate those models, to the different kinematics areas of the machine. So,
Perfect. So I guess the answer would be yes to both, depending on the situation.
Correct.
And for everyone, also, I'm going to attach my email. I know sometimes not everything, you don't have time, or maybe you think of something afterwards. My general contact info is on there, so you guys will be able to reach out, and we'll be able to get hold of Ryan if there's something above my understanding. So perfect. Hopefully that answers your question, Joel. So give it a few more minutes here, see if anything else comes in. But
yeah,
it was great. I really appreciate all the help, Ryan.
Of course, yeah, not a problem at all. So yeah, we'll obviously be hanging around for a few more minutes in case there's obviously any last minute questions that kind of come in, or want to ask anything else. Otherwise, we'd be happy to definitely take anything offline and set up a conversation individually as well, if that'd be a better fit too. So
perfect. One thing I want to add also, I know we're planning here. I don't know if we have a firm date. In the next month, 2 months, something like that, we want to have another webinar for like DNC, MDM, and kind of cover more of those, I guess, in-depth file transfer, data management, that type of stuff. It's not near as flashy and as fun as CIMCO Probing or Edit, but nevertheless, it's still, you know, a good pain point that people have that maybe we can provide some kind of service for. So,
Of course, yeah, and obviously, you know, kind of looping that all together and you know, coming full circle as part of it. So,
perfect. Well, I don't see any other questions come in. Matt said, thank you for your time. Perfect. I appreciate everyone's time. Unless Erica or Jason, unless you guys have anything you'd like to add, anything myself or Ryan might have missed. I appreciate everyone's time. I know how difficult it is to pull you guys away from the shop, away from the machines, away from management, whatever your role might be. So, it means a lot to us. All right. Well, perfect. Yep. Thank you too. Appreciate it. Thank you, Derwin. Thank you, Chris. We'll see you guys all next time.
thanks, everyone.